you're going to optimize costs, strike faster, guarantee safety, and avoid delays, all whilst reducing your carbon footprint. With us, being the good guy, easy. And because ConcreteDNA is in the cloud, teamwork has never been easier. Anyone can access the data from anywhere at any time. Okay, how simple is it to set up? That simple.
Hi, I'm Gideon, one of the co-founders and CTO of Converge. My background's actually very far away from construction, originally an astrophysicist, and I've been programming most of my life, so I guess software astrophysics. But you know, when I met my co-founder, we met a long time ago in our first week at Cambridge. We're both physicists, in fact. And a lot of people thought that, you know, physics, construction, like what's the connection there? But, you know, really, physics is about, you know, you take the physical world and you try to model it and you try to make predictions about it. So, in a way, when we left university, we finished our master's degrees. We ended up on this program called Entrepreneur First, which was a startup incubator in London, and we were really looking for a way to have a global impact. And we looked around at many different industries, and we really wanted to use these skills that we developed in physics about, you know, analyzing sensor data, modeling the real world, that sort of thing. And you know, we came across this customer, Langerock was our first customer, in fact, really impressive construction company, one of the biggest in the UK and in Europe. And they were telling us about some of the problems they were having with, you know, understanding what was really happening on site. And we realized that we could apply exactly what we've been used to doing in physics, which is, you know, you instrument a system and then you model it, to the construction industry. And in fact, construction was almost like a perfect fit for us in this regard, because it's this huge industry at 10 to 15% of global GDP, and yet it's the second least digitized industry in the world, the most under-digitized industry in terms of the heavy industries. And that meant that there was this huge opportunity for this very, very complex industry and to truly revolutionize it. And what we realized is not only were there serious operational inefficiencies being caused by the lack of digitalization in the industry, but it was also deeply, deeply unsustainable. And yet, construction's not going anywhere. It's, you know, a very fundamental industry to human society, and so, you know, you can't imagine humans existing without building buildings. And so if we're going to build the future, we have to build it more sustainably and more efficiently. And we realized that that was really our calling. And that's what we wanted to dedicate our time to. And so, you know, within the construction industry itself, you know, it's got this huge productivity gap caused by this massive, you know, under-digitalization problem, as well as these sustainability issues. But you can't improve what you don't measure, right? So we realized that the biggest problem in the industry was not a complete lack of digital tools, because there are tools for checklists and task lists and document control and that sort of thing, but there was a real lack of physical data in the industry. And what we meant by that is, you know, measuring the source of truth with sensors. And so we realized that what we could do is instrument construction sites and factories and logistics pipelines and that sort of thing with sensors, and then use those data to create a model of how the industry is performing, and, you know, feed all the data into things like the BIM models and the construction schedules. And then we can start to connect the dots and gain all these new insights about, you know, what's actually going on a project. And actually BIM is really important for that, because it's this medium through which we can really communicate progress, communicate issues, and contextualize these like vast, diverse forms of data. And then it gets really exciting when you start to amass these huge amounts of data, and you can then start to apply machine learning techniques and, you know, what people call sort of AI. And you can start to generate real insights that humans couldn't connect those sorts of correlates. So you can start to do things that humans couldn't really do, and you can provide more than just data to people in the construction industry. So data-driven decision-making, very, very important, but more than providing just data, you start to provide actual intelligence. So you start to give humans intelligence that they couldn't otherwise gather about what's happening on site and how to mitigate certain problems. And this gives us a whole new set of levers to pull on to build the future more efficiently, safely, and sustainably. And, you know, this is a pretty lofty ambition. So we had to start somewhere in the industry, because it was too early when we started 6 years ago to start talking about this wider vision. So we tried to find a very specific use case, and we did. We settled on the concreting process. And because there was a real day zero value proposition that we could tap, which is in monitoring concrete strength and also to concrete temperature profiles for mass concrete pours. And that had a very distinct operational benefit, which is that if you're building, say, a skyscraper and you're trying to build floor 30, you need to know that you could load floor 29 and strike the formwork and so on. So by providing those data in real time, automatically, and then we also built a predictive engine which would be able to predict concrete strength, up to sort of 96 hours in the future, which allowed people to plan their operations. We saved, about 30% on a lot of cycle times on certain types of buildings, especially where concrete's on the critical path. So that was a very easy, well, not easy, but a very obvious day zero value proposition that we could deliver to the industry, that they understood, and that had these traits of being about physical data and construction data, so things like the mixed designs, the BIM models, 3D drawings, rebar diagrams, that sort of thing, and sort of combine all these things together to give them actual intelligence about how to increase the operational efficiency on their projects. So by combining information across different sort of sections of the construction life cycle, all these different processes that happen, you can start to really sort of deliver things that you wouldn't really expect. And actually, so for example, as I mentioned, ConcreteDNA products improve cycle times by up to sort of 30% on some types of products, especially comparing it to traditional concrete testing methods, which are also less accurate. And we've also been using the data to try to drive significant CO2 savings by optimizing certain types of materials or reducing waste, that sort of thing. And our technology has been used by a major tier 1 contractor in the UK to do precisely that. And we're optimizing the carbon of modular structures using low carbon concretes, and we're showing about a 45% total saving in CO2. And then, very sort of serendipitously is the wrong word because the pandemic's been terrible, but one of the things that's really pushed is this move towards more and more requirements for remote monitoring on site. So as we're trying to reduce the number of people on site for health safety reasons, remote monitoring becomes more and more important. And with these wireless real-time sensor networks that we build, you can actually see what's going on the site, but you don't have to be there. You could be on the beach, or like most of us, locked in our homes. In terms of how this works for the customers, all it's really about is you're embedding these sensors in the fabric of the building, and different sensors do different things. So the concrete sensor monitors temperature and relative humidity, and then we have other sensors which monitor things like strain and tilt or location. But it's all about you're trying to monitor the actual materials and the logistics of these projects. And once you do that, the data gets pulled up to our cloud platform, and then you can, instead of watching Netflix, you can watch your concrete drive. And the system is designed to be quite plug and play, so you really believe in being open and interoperable, so that you can plug into all these other systems. Because I don't think there's going to be just one company that will do all of construction technology. Really, it's going to be a big ecosystem, and we want to be a good citizen of that ecosystem and be very sort of open and interoperable. I think that the big trend that we're seeing in construction is obviously towards much more modular construction, and that will allow other forms of optimization. And so I think we'll start to see more and more instrumentation, more and more sort of factory building, and we'll see the feedback. I think where it gets really exciting is you'll see the feedback loop start to tighten. So by monitoring these things and building them in a factory, you're managing to see, okay, we varied this design type or construction methodology, how did it perform in real life? Because that's the thing that's really been missing in the industry is a well-instrumented system which allows you to say, how did this theoretical design perform in the real world? And that's really powerful, because then we can start using machine learning techniques and other forms of data processing to really understand, well, what works and what doesn't. And then we can start doing generative designs. We could actually have buildings which are far more structurally sound, while also being much less wasteful of materials. We can reduce the over-design of buildings, and we can be using much more environmentally sustainable materials that cause less damage to the planet, all by instrumenting our buildings and their life cycles, so that we can feed data back into the design process, so that we get better buildings, and we can then, that way, build the future more efficiently, safely, and sustainably. I think my main piece of advice for young entrepreneurs, well, I mean, there are many things one could say, and many lessons to learn, but I think one of the biggest has often been don't make decisions based out of fear. Because I think whenever you make decisions based out of fear, you tend to miss opportunities. And that fear can take many different forms. And I think there's this balance that needs to be struck between knowing when to hold on to a hypothesis or an idea and knowing when to drop it. And it's really hard to work that balance out actually, and it's on a case-by-case basis. But whenever there's fear involved, whenever you're scared of making a particular decision or dropping a particular idea, you almost always make the wrong choice. And I think that would be my sort of core piece of advice.